Hi everyone, welcome back to VRC Smart Edu channel. So today we are here with chapter 11 Alcohols, Phenols and Ethers of Class 12 CBSE Chemistry. Okay, as I said earlier, this is organic chemistry. So part 2 of this chapter, and already we have completed the part, as I said, part 1 video we have already completed. The part 1 video link is provided in the description, as well as the previous lesson organic chemistry previous lesson also we have completed. That lesson link and the previous question link also provided in the description. If you need, you can go and check it out. Okay, now today we are going to look after the preparation of alcohols, only the preparation of alcohols. So we will go slowly. Okay, so just you have to note down all the information, whatever I give, note down and keep it. Okay, so we will go with preparation of alcohols today, very simple concept. Okay, so only preparation of alcohols we are going to deal today. If you like this video, kindly hit the like button, share this video with your friends and family members, support us and kindly subscribe to our channel for more videos. Enter into the preparation of alcohols. Okay. So now preparation of alcohols. If you just say preparation of alcohols, the preparation of alcohols divided into three categories. Okay. You can prepare the alcohols from alkene, and you can prepare it from carbonyl compounds, and you can prepare it from Grignard reagent. So from alkene, the preparation type is divided into two. From alkene, the preparation type is divided into two. So first one is acid catalyzed hydration. Acid catalyzed hydration. Second one is hydroboration oxidation. From carbonyl compounds also it is classified into two types. First one is reduction of aldehydes and ketones. Reduction of carboxylic acid and esters. Okay, so this classification of preparation of alcohol is very important. First you should know from what are the things you can prepare the alcohol. You can prepare the alcohol from alkene, from carbonyl compounds and from Grignard reagent. From alkenes you can prepare it two types: acid catalyzed hydration, hydroboration, oxidation. From carbonyl compounds, two types: reduction of aldehydes and ketones, reduction of carboxylic acids and esters. From Grignard reagent. So these are the things you have to remember. So now let us see order by order all the informations. Okay. So first, what the thing we studied is from alkene we can prepare it two methods. So one of the method is acid catalyzed hydration. So in acid catalyzed hydration, let us take the alkene. Okay, first I am taking CH2. Okay, CH2 double bond CH2. This is symmetrical alkene. So whenever you are doing acid catalyzed hydration, you always react it with water. Okay, water, H2O. Okay, so your H2O, how the H2O will be breaking? The H2O will be breaking into H plus and OH minus. So here, whenever you are doing the acid catalyzed hydration, you have to follow the Markovnikov's rule. So in the previous class, that is class 11, you have studied the Markovnikov's rule. What does the Markovnikov's rule say? That in an unsymmetrical alkane or whatever the alkene you take, the compound you are taking, no, in that positive compound will be there, negative compound will be there. The negative part of the compound will be getting attached to the carbon containing less number of hydrogen. Okay, that is for unsymmetrical alkane. Both are symmetrical alkane, both are having same number of hydrogen, so no problem in the first condition. So you can attach the OH in any one of the place. Either if you attach here or here, both are going to be the same compound, right? So you can attach OH to the either of the position. You can attach the OH. You have to break the one of the bond. So your H will be going and attaching to one of the hydrogen carbon, and your OH will be going and attaching to one of the carbon. So it is going to become CH3 CH2 OH. So H plus is there. H is going to go and attach to one of the carbon, and OH is going to go and attach to one other carbon. Now if you are taking the unsymmetrical alkane, let us see CH3, then CH double bond CH2 plus H2O. Now you know H plus and OH minus. So what you will get as your result? See, the OH will be getting attached to the carbon containing less number of hydrogen. That means to the center part of the hydrogen, OH will be attached. You should not disturb the CH3 because you are not removing any of the bond in CH3. So CH and CH2, you have to just do these two compounds. So CH2, what will be going and attaching? H plus will be going and attaching to CH2, becoming CH3. Bond will be broken, single bond. CH to CH, what will be going and attaching? OH, because least number of hydrogen. That rule, Markovnikov's rule. So CH3, CH to this OH will be attached, and CH3 will be there. What is this? This is propane to all. Propane to all you will be getting. Clear? Now, for this you have the mechanism, and this mechanism is very important. Okay, mechanism to understand is very important. So mechanism has 3 steps. Step 1. Okay, step 1 is protonation of alkene. Okay, protonation of alkene or formation of carbocation. Okay, protonation of alkene or formation of carbocation. Formation of carbocation. See, here what we are going to do is we are going to convert the alkene to alcohol. So I am going to convert the ethene to ethanol. So for that I am writing the mechanism step by step. That is, see, directly I told we are following the Markovnikov's rule, so that the negative part is going and attaching. All these we discussed, but we should know how step by step this process is occurring. For that only we are writing the mechanism. So here the mechanism is for the conversion of ethene to ethanol. Okay, first we are taking the ethene. Ethene is CH2 double bond CH2 is the ethene. Okay, or I will write the expanded structure so that you can understand very easily how this process is happening. So CH2, right? So one H, another one H, double bond CH2. So protonation of alkene means nothing but when you add H plus, ion, that is the meaning of protonation. H plus is a proton. So when you add H plus, then it is called as protonation of alkene. That results in the formation of carbocation. So this H plus, what will happen? This H plus will go and attach to one of the carbon and forming the C, H, H, H. And what happens is the double bond will be broken into single bond, and see here 2H only will be there, forming the carbocation. So protonation of alkene resulting in the formation of carbocation is your first step. So protonation of alkene means what? You are adding the H plus. This H plus will be going and attaching to one of the carbon, so that the double bond will be broken into single bond and carbocation is formed. So second point is going to be, that is the second mechanism that is going to happen is attack of nucleophile. Attack of nucleophile. So attack of nucleophile to carbocation. So now in the attack of nucleophile, what we are going to do is we are going to take this compound C, H, H, H and C, H, H. Then carbocation is formed. To the carbocation, nucleophile we are going to add, that is water. Water is what we have, nucleophile. So attack of nucleophile is going to result in what? Attack of nucleophile. So H2O will be going and forming it as something like this. So here, see, this C will be as it is, no disturbance here. C, H, 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 H. Now C, H, H. To the C, O will be attached. Two H's are there, no? O, one O, two H. So O, H, H will be attached. And here one cation will be formed. Here one cation will be formed. Now, what is going to happen is, listen carefully here. Okay, very important step now. You are going to remove that cation. That is, you are going to remove that protonated. So, that protonation, if you have to remove, the step is called as, the third step is called as deprotonation. Deprotonation. So, in the previous step, what is the compound that we had? C, H, 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 C, H, H, O, H, H. So this is a compound that we had. Okay. Now deprotonation means you are going to, that is here positively charged. So that proton you are going to remove. That proton you are going to remove. So in the deprotonation reaction, what happens is your C, this H, H, H will be as it is, and this C, H, H will be as it is. Now this, in this OH, this H is going to go out. This H is going to go out. So now you see O, H will be there, plus H plus will be going out. So now it is completely satisfied. So forming the ethanol. Forming the ethanol. So this is nothing but ethanol, right? So forming the ethanol. So this is a mechanism that we follow to form ethene to ethanol. So what is the first steps we followed? We followed the first one is protonation of alkene or formation of carbocation. So protonation of alkene or formation of carbocation, we used, first we took the alkene, that is ethene. You are just protonation in the sense adding H plus so that the formation of carbocation took place. An attack of nucleophile. So nucleophile is water. When you attack the nucleophile, what happens? O double H will be formed, that is going to attach to this compound, forming the cation. So third step is deprotonation. Always you should remove the proton that is forming. So deprotonation. In the deprotonation reaction, what happens? Your one of the H will be going out as H plus, forming the alcohol. Clear? This is a mechanism to convert ethene to ethanol. Now moving on to the next process. Okay, that is also from alkene to alcohol. So this process is called as hydroboration oxidation. Hydroboration oxidation. So hydroboration oxidation, here how to do this I'll tell now. Listen carefully. First we are going to take the propane. So if you are ready to convert to propane, prop 1 okay, prop 1 to propane 1-all. Then this process you can use, hydroboration oxidation. Okay, so first I am taking the propene. So what is your propene? CH3, CH double bond CH2. This is your propene. So now to the propene you are going to add HbH2. To the propene you are going to add HbH2. This is a compound that I am going to add. Now HbH2 when you add, what happens is, this is going to split into H plus and BH2 minus. So what will happen? H plus and BH2 minus. So you know that this is also going to, BH2 is going to go and attach to the carbon containing, here it is going to follow the anti-Markovnikov's rule. Based on the anti-Markovnikov rule, what you can say, the negative part will be going and attaching to the carbon containing more number of hydrogen. Right, so that is anti-Markovnikov's rule. Here it is going to follow anti-Markovnikov's rule. So your BH2 minus is going to go and attach to the carbon containing more number of hydrogen. So here which is containing more number of hydrogen? CH2. CH3 you should not touch because it's not having double bond. Here you are removing the double bond. So be careful, you should not touch CH3. So next to CH2 is having the more number of hydrogen. So go and attach with it. So what we will get? CH3, CH2, CH2, BH2. Okay, BH2. Now this BH2 is going to be splitting into BH2 is going to be splitting into H plus and BH minus. H plus and BH minus. So now what happens? Again we are going to react the propene. That is, I am going to take the CH3, CH double bond CH2. Again I am going to take this compound. So what you will get is this CH3 here. This H plus will be going and attaching over here. And BH will be going and attaching over here. So CH3, CH2, CH2 will be common. Right? CH2 twice. So BH you will get. Because see BH2 is divided into H plus and BH minus. So finally you will get BH. Right. Now again what I am going to do is BH will be splitting into H plus, B minus and H plus. So what happens is again I am going to react with the same compound CH3, CH double bond CH2. In the presence of it we are going to get, see this B will be attaching to this carbon and H plus. H plus is going to attach here, B going to attach here. So you are going to get CH3, CH2, CH2 thrice B. Now this compound I am going to react it with water. This compound I am going to react it with water. Okay. When I react it with water, you know it will be splitting into H plus and OH minus. You all know very well, right? So now what we are going to do is we are going to get the product as CH3, CH2, CH2, OH plus H3BO3. Orthoboric acid. So this hydroboration oxidation. So finally you are going to get the release of orthoboric acid. Orthoboric acid. Okay, finally the liberation of orthoboric acid you are going to get it. Clear everybody? Right. So be clear with this, how it is splitting, and finally what you are getting, all this orthoboric acid. Next we are moving on to from carbonyl compounds. From carbonyl compounds, the first one is the reduction of aldehydes and ketones. So reduction of aldehydes and ketones. First you are taking the aldehydes. So whenever you take the aldehydes, you will get the primary alcohol. Okay, whenever you take the ketones, you are going to get the secondary alcohol. This is one of the key thing you can remember. Okay. Now reduction of aldehydes and ketones. First I am taking the aldehyde. RCHO is the aldehyde, right? CHO is the aldehyde group. So with any R, that is alkyl group, RCHO makes aldehyde. So aldehyde group, when it is going to react with Ni in the presence of H2, Ni in the presence of H2, it is going to get the primary alcohol RCH2OH. RCH2OH is a primary alcohol. So when we are taking the ketone is C double bond O with another two bonds, it's going to form with the alkyl group. In the presence of NaBH4, this catalysts are very important. So most of the students will go wrong in the catalyst. They will change and write the catalyst. So catalyst is very important. So in the presence of NaBH4, it is going to form C double bond, that is R will be formed. Okay, with I told it is going to form the secondary alcohol. Secondary means to CHOH. Secondary alcohol. Okay. So the aldehydes are going to produce the primary alcohol. Ketones are going to produce the secondary alcohol. Right. So now listen carefully over here. See, this can be this. So now let us move to the reduction of carboxylic acid and esters. Okay, carboxylic acids and esters. Esters. Okay. So now listen here. So first of all, when you are reacting with carboxylic acid, that is the first thing you see here, RCOOH. COOH is a carboxylic acid. R is nothing but alkyl group, you know very well. RCOOH is a carboxylic acid. When the carboxylic acid is reacted with AlH4, the presence of H2O, you are going to get RCH2OH. That is, you are getting the primary alcohol. Primary alcohol. So, next, you are going to take the ester. Okay, you are going to take the ester. Ester is nothing but RCOO. R is a ester. Ester in the presence of water, simply you are reacting it with water, you will get, see, RCOOR is there. So, first, RCOOH. So, R will be replaced by H, right? So, and ROH. ROH. That is, see, RCOR, you can keep it as minus and R plus. So, it is going to divide into H plus and OH minus. So, what is happening is, this H plus is going and attaching to RCOOH. OH is getting attached with R. Something like this, the reaction is formed. Or you can also do it something like this. You can write it as RCOOR in the presence of Ni and H2. Ni and H2, you will be getting RCH2OH plus ROH. This is also one type of reaction that can be done with esters. Clear? Now, moving on to the last reaction that can be done for gaining the alcohol is from Grignard reagent. So, from Grignard reagent, you have to remember certain things. So, listen here. See, if you are going to take the formaldehyde. So, formaldehyde is nothing but methanol or methanol. Anyway, methanol. Okay, methanol. This is always going to produce the primary alcohol. Other aldehydes is going to produce the secondary alcohol. And if you are going to take the ketones are going to produce the tertiary alcohols. So let us see the formaldehyde first, then we will move to other aldehydes and ketones. Okay, all the three we will be just looking after. Clear? All the three we will be seeing now. So first we will be going to formaldehyde. What is formaldehyde? Formaldehyde is methanol. So C attached with H double bond O. This is methanol. So first step for Grignard reagent is you always react with RMgX plus RMgX. So what is your R? R is your alkyl group, CH3 or C2H5, any group. Mg is common. X can be Cl, Br or I. Chlorine, bromine, iodine or fluorine. Your I can be these compounds. Okay, you already know it. You have learnt it in your Haloalkanes and Haloarenes chapter, right? So, RMgX. Now, what you are going to do is, you are going to react. When you are going to react, what happens is, see, R will be becoming as R minus. Okay, so the C plus will be there and O minus will be there. Okay, and mgx plus r minus. Like this you will be getting the formation. C plus r minus mgx plus O minus. Now the positive and negative will be getting attached. The negative and positive will be getting attached. Double bond will be broken first. So CHH will be as it is. So since it is positive, first to the C what will be getting attached? R will be directly getting attached. To the O what will be attached? mgx will be getting attached. Now we are going to react. What we are going to react? We are going to react water with it. You know, all know water is going to split into H plus and OH minus. So what a compound you can expect over here? See, H and H will be as it is, you know very well. And here R is there, O minus mgx plus. So now what happens is H plus and OH minus. Okay, so what happens is this mgx will go out as mgx will be going out. Instead of mgx, to the OH will be coming and attaching, and the thing you will be getting is plus, you will be getting mg, or I'll write this plus, you will be getting mg, OH will be attached and x already there. So this is the result you will be getting. This is the result you will be getting. OH is going and attaching over there. Clear? For this is for formaldehyde. Now what if you take the other ketones? Other ketones, I am taking CH3, H double bond O. First step is always reacting with R mgx. So R minus mgx plus. So this is C plus O minus. So the same step, same reaction. So CH3 and H will be as it is. What happens here? R will be coming directly and attaching because it is positively charged, and to the O, mgx will be coming and attaching. Now what you will be reacting? You are reacting it with water. Water will be becoming H plus and OH minus. So what happens? This is O minus and mgx plus. So what happens is CH3 H O mgx, instead of mgx, H will be coming and attaching here, R plus mg. What will happen here? mg OH will be coming and attaching here, X will be there. So this is for what? Other aldehyde. So what if it is going to be? What if it is going to be ketones? Ketones. Okay, so now I am taking the ketone. Ketone CH3, 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 double bond O. Now we are reacting with R mgx. So now also this is plus, this is minus, this is minus, this is plus. So the same process will happen over here also. What happens? CH3 will be as it is. CH3 will be as it is. See. Okay, these two bonds will be as it is, and to this what is going to happen? R and O mgx is going to come and attach, O minus mgx plus. So again reacting it with water, what happens? H plus and OH minus, it is going to split into. Now what happens? H is going to go and attach over there. So CH3. Now here it is going to be O, H and R. So this is tertiary halide, correct? So tertiary. So next you will be getting plus Mg, OH and X. So this is how you will be getting your reaction to occur. This is tertiary alcohol, right? This is tertiary alcohol, and what you got over the previous two things, this is the secondary alcohol. This is the secondary alcohol. So how we are saying it is as secondary alcohol means, listen carefully. CH3, C. So one of the bond is attached with H. So if you write means CH will be there here. If any other bond is there, R. So CH means what? CH in the sense this is secondary alcohol. This is primary. Primary means see, two H's are attached, so you will be getting CH2 for this carbon. So that means it is primary, right? So primary. Now tertiary in the sense, here if you just see in this reaction, no H is attached for C. So C, no H is attached, but other compounds are attached on the four sides. So this is tertiary alcohol. Okay, if you can understand, then you can understand it very easily, right? So that is why we are getting the tertiary alcohol. So this is how you have to react it when it comes for Grignard reagent. When it comes for Grignard reagent, the methanol will have the primary alcohol, other aldehyde second alcohol, ketones tertiary alcohols. This if you remember, then while doing the problems or while solving the equations, it will be easy for you. So that's all for today's video. Thank you so much for watching this video. If you like this video, kindly hit the like button and share it with your friends and family members for sure. And the previous lesson and the previous video links are provided in the description. If you want, you can go and check it out. Watch those videos also for your complete clarity. And PYQ also we have made for the previous lesson, that is also provided in the description. You can go and watch it. Okay, so make sure you understand the concepts, and if you like this video, kindly hit the like button, okay, and subscribe the channel. So in the next video, I'll meet up with the preparation of phenols. Okay, until then, bye.